Hi guys, how are you? I hope you are feeling well and that you're ready to go back to work. Today we're gonna keep doing trigonometry this week. Actually, all week we're gonna do special triangles, and these are triangles that have a special ratio between sides, and that's what we want to look at. Before that, let's, as a reminder, SOHCAHTOA, right, stands for sine. Remember the definition of sine is the opposite side over hypotenuse, always hypotenuse being the longest side. Then we have the cosine is the adjacent, which is this one, the one touching the angle. This is the opposite, it's the one across the angle. And then this is the adjacent, so the cosine is the adjacent over the hypotenuse, and then tangent opposite over adjacent, right? Okay. Remember that if we, instead of looking at this angle, we look at this one, the opposite would be this one, and the adjacent would be this one, okay? While the hypotenuse never changes, okay? This is just a reminder. And then the first exercise we have for this week, we have a special triangle. And this is a special triangle because if you look at it, it has a 45 angle here. Okay, this is a 45. Let's use another color. This is a 45. This is a 45 angle. If this is a 45 angle and this is a 90, because we know that all angles of a triangle, they have to add up to 180. Okay, we know that 45 plus 45 is going to be 90. 90 plus 90 must be 180. So then this must be also a 45 angle, right? Now, what it's new from the last week is that we're going to use this table. And this table tells us that the sine of 45 is square root of 2 over 2. And that the cosine of 45 is square root of 2 over 2. And then that the tangent of 45 is 1. Okay, so for the first one, that's what we're gonna use. Okay, again, we're gonna write it down here. Let's write it down up here. So we have it. The sine. I'm gonna write it up here. Okay, the sine of 45 is square root of 2 over 2. The cosine of 45 degrees is square root of 2 over 2, and then the tangent of 45, it's 1, right? Knowing this, we can proceed to do this type of problems. So we have, okay, here we would like to know y and x, and we know that this is 45 and this is 45. Let's use this one, oh, sorry. So, as said, we have again, sine of 45 would be opposite over hypotenuse. If we take this one, sine of 45, as we have two variables, we are going to be unable to find any of those, right? We need to use this side to find either x or y. So we can use, as this is the adjacent, we can use actually cosine, or we can use tangent. It doesn't matter. We can. There's many ways to do it. So let's start with cosine. Cosine of 45. It's gonna be cosine of this one. This is the adjacent of this 45, and this is the hypotenuse. So as cosine is adjacent over hypotenuse, we're gonna have 3 for the adjacent and x for the hypotenuse. So that's the equation we need to solve. Cosine of 45 equals 3 over x. Okay. The way to solve this equation, we can again multiply times x both sides and then divide 40 cosine of 45 both sides. I find it much easier if you guys exchange this with this. I think it's the easier way to solve this kind of equations, okay? So we have then is x equals 3 over cosine of 45. Now, we have it up here. Cosine of 45 is square root of 2 over 2, right? So we're gonna do 3 over square root of 2 over 2. We're trying to divide 3 over square root of 2 over 2. Let's remember how division works, okay? Remember, division works this way. Division of fractions. So we have 3 over 1, because 3 and 3 over 1 is the same thing, divided over square root of 2 over 2. And remember, when we divide fractions, we just cross multiply, okay? So what we have is 1 times square root of 2, square root of 2 at the bottom. And then 3 times 2 is 6 at the top. So the answer is 6 over square root of 2. Okay? Okay, so that's for x. Now, how do we solve for y? Well, for y, we have, now this is 6 over square root of 2. And now, how do we find y? We're trying, it's important to point that we're trying to give exact solutions. So please use this so you get exact solutions. Don't use the calculator for this, okay? Now for y, let's do it for y. So for y, we can use either tangent or we can use sine, because now we have this one, it doesn't matter. So I'm gonna use tangent, you can use any. So tangent of 45 is gonna be opposite over adjacent. It's gonna be y over 3, right? Now, how much is tangent of 45? Tangent of 45, it's 1, right? So, so we have 1 equals y over 3. If we multiply 3 both sides, we have that y equals 3, which is actually obvious, because when we look at this triangle, we actually see right away that if this is 3, this must also go 3, because if it's a 45, 45, 90, this leg must be the same as this one, okay? So that can help you to solve these problems quicker, because if this is 5, this must be, okay? The legs are the same for 45, 45, correct? Okay, now if we want to solve this quicker, we can actually understand, let me show you. We can actually understand that actually a 45 triangle, okay, all of them, I have 3 of them here, all of them have the same proportion. This is a 45, 45 angle, 45, 45, I'm sorry, 45, 45, and all of them share this 90 right angle, because they are actually right triangles, right? So this side must be the same as this one. Now, if it has the same proportion, we can use actually what we have in here. Look, if we know that this is 1 and this is 1, then this is square root of 2, okay? Let's suppose that this is 2, then this will be 2 square root of 2. Let's suppose this is 10, then this will be 10 square root of 2. This will be 10. Okay? Let's suppose this is square root of 2. If this is square root of 2, then this must be square root of 2 times square root of 2, which would be actually 2. So when we go from here to here, we're multiplying the square root of 2. When we go from here to here, we're actually dividing over square root of 2. Okay? So that's the proportion. So if you know this, you don't even have to use trigonometry. You can do this right away by doing, this is 5. Okay, I know that this must be also 5. And I know that this must be 5 square root of 2. Here, it's the opposite. They're giving us the hypotenuse, and we have to find the leg. When we go from the hypotenuse to the leg, what we have to do is divide over square root of 2. If this is 9 times the square root of 2, and we divide over square root of 2, this must be 9. So then I know that this leg has to be 9, and this one has to be also 9. Okay? For this one, which is the same actually, right? We have to divide over square root of 2, because we go from the hypotenuse to a leg. Again, from going from a leg to a hypotenuse, multiply square root of 2. From hypotenuse to a leg, divide over square root of 2. So we have to divide, right? So here we have 2 square root of 6 over 3, right? Now we have to divide, right? Over square root of 2. If I write it like in a fraction way, 2 square root of 6 over 3 divided over square root of 2 over 1, right? And then we cross multiply, and we're gonna have at the top, at the top, we're gonna have 2 square root of 6 times 1, 2 square root of 6 over 3 over 3 times square root of 2. Now, how do we simplify this? We have, let's do a line here. So 2 square root of 6 over 3 square root of 2. You can remember when we studied powers that square root of a over b is the same as square root of a over square root of b. So what we have here actually is the square root of a over square root of b. So we can proceed to put it together. Okay, so this is going to be 2 over 3 square root of 6 over 2. As long as it's the same root, like square root or cube root or ninth root, whatever, if it's the same, we can put it together. So now this is 6 over 2, which is 3. So we have 2 over 3 square root of 3. Okay? And this line, you can just put it like this, or you can just extend it like this. It's the same thing. Okay? And that's it. We cannot simplify further. Okay? That's it. So that means that this is going to be 2 square root of 3 over 3. And this is also going to be the same because it's a 45-45. So it's going to be 2 square root of 3 over 3. Okay? Now, you can do 5 and 6 because it's the same, right? And then for 7, okay, for 7, this is another type of triangle. It's a 30, 60, 90, okay? So here I have this example, the same thing, but it's a different type. But we have a 30 here and a 60 here and a right triangle here, 90 here. Okay, so you know what, I'm gonna do another video to explain this one. Okay.